In this video, let's try to learn the jump searching algorithm. But before this, we learned about exponential searching algorithm, right? So what exactly we did in the exponential searching algorithm? In exponential searching algorithm, we are basically given an array of values. In that array of values, we did not wanted to apply binary search on the entire array. For that, we tried finding the possible range or the block size of the array in which we can apply the binary search so that we can find the respective position of the value that user has given. But in the case of jump searching algorithm, the algorithm is exactly similar. It's just a small change that for finding the block size, whatever the range calculation that we have done, that changes a bit. Based on that change, we call this algorithm as a jump searching algorithm. So how the range calculation happens inside the jump searching algorithm is basically in the beginning we will assume or we will define the size of the block with a constant length. In specifically when we implement the jump searching algorithm, right, we will basically define the length of each block as root of n, square root of n. This here n is nothing but length of array and square root of n is nothing but the size of the block in each and every iteration that we are going to consider. So again, in the case of jump searching algorithm also, there are two steps. As part of the first step, what we will do, we will try to see if the value is inside a block of constant length that we have assumed that it will be of root n, and once we come to an understanding that the value is in that range, we can either apply linear search or binary search on that block of the array so that we can accurately find the exact position at which that value is available. So let me explain you the same thing with a simple example. But one thing that you have to remember is even jump searching can also be applied on a sorted array only. If the array is not sorted, since the values are in randomly arranged in the array, we can't find the exact position using the jump searching algorithm. So array has to be sorted. That is something that you have to note down here. Let's assume that the values of the arrays that we have here are minus 71, minus 51, 11, 19, 27, 57 and 76. Totally we have 7 values in the array that we have been given. And let's assume that the value that user wants to search is, let's say, 27. Okay. Now as part of the first step, what I told you, we will assume a block of fixed size, right? That fixed size is nothing but root n, square root of n. Here we have 7, right? 7's square root, if we do square root of 7, it will be something related to 2 point something. So what we will do, we will simply floor it. So the block size is 2. Now what we will do is, we will iterate over the entire array, and what we will basically do is, we will compare the elements at every block size. That means here if we assume the block size of 2 in the beginning, right, we will be at the index 1. Now what we will do, we will compare the value at index 1, which is minus 51, but the value we want is minus 27. So it is still on the right side of the right part of the array. So what we will do, we will again increment the size by 2. In that case, the block size or the last index block size will still remain 2, right? That's why we are considering block of 2 elements continuously. In that case, we will reach the index 3. At index 3, we have value of 19, but the value that I'm looking for is 27. So what I have to do, it is still on the right side of the array. So what I will do, I will consider the next block elements. So by considering next block elements, I will come to the index 5. At index 5, I have a value of 57. So 57 is smaller than 27. That means that the array is on the left side. Okay. Right now, on the current position that we are at is 5. Okay, but as part of the previous iteration, we reached the index 3, right? Because we are considering a block size of 2. As part of the second iteration, we have already compared the index 3, right? So that means it will be in between these three values. Okay, technically this value, this index also we have compared, right? So it is not matching with that index. So obviously the value will be between index 4 and 5. Now what we can do here, since we have only two values, right? We can simply perform linear searching. If the block size has more number of values in it, you can perform binary searching also. It is up to your wish, either you want to perform linear search or if you want to perform binary search, once we come to understanding where exactly the value could be present. Okay, so now what we can do, we can simply perform the linear searching algorithm here. So what I will do, I will run a loop from 4 and 5 because 5 is the current last index and 3 is the index that we have checked as part of the last but one iteration. So I will simply start with 4 and I will simply compare each and every value. At index 4 itself I have the value 27, so I will return index 4 as output. Okay, if the value that user wants to search is, let's say, 28, so obviously it will be in the same range, right? If since we are simply iterating it over each and every value in that block size, if the value is not available, since the value is not available, we will simply return -1. Okay, that is the major difference of implementing jump searching algorithm compared to exponential searching algorithm. Once again, let's try to revise what exactly we are doing. In the beginning, in the exponential searching algorithm, we are starting with index 1, and again to find the appropriate range or the block size in which the value is present, we are simply multiplying that start index by 2 such that we can find the minimum and maximum ranges for applying binary search. But in the case of jump searching algorithm, that block size, what we will do is we will assume it is of constant length. So that constant length, you can assume this length also anything, but here as a general practice it is always assumed that square root of n. Here since we have 7 values, square root of 7 will be 2 point something. As a result, we will floor that value to get the whole number. Once we get the whole number, we will iterate over that many number of elements, and in that block size we will compare the last index's value with the value that user has given. If it is matching, we will search in that range. If it is not matching, we will simply move on to the next block of value which could potentially contain the value that user has given. Okay, that's what we will be doing in the jump searching algorithm. Please remember that it is also applicable on the arrays which are sorted only. Okay, now that we have understood the algorithm behind it, let's try to write the pseudocode for it. Okay, pseudocode of jump searching. Okay, here as part of the implementation, let's simply put whatever we have discussed previously into words. For that, we will simply be writing a function called jump searching. It will take array of values and the value that user wants to search in the array. So as part of the first step, what exactly we did, we calculated the block size. So the block size is nothing but square root of length of array. Okay, once we get the block size, what we did, we compared the last element in that specific block as part of the previous one. To get that last block index, how we will define a variable called last index in block. Okay, the last index will be block size -1 when we begin. In our example, we had array of size 7, so the block size we got is 2, and the first index that we had to compare was index 1, right, which is nothing but the block size -1. So we will simply get the last index in the block size by simply subtracting 1 from it. Now what exactly we need to do, as long as there are matching part of the arrays that are there, that means this last index hasn't reached the end of the array, that means this last index in block is less than length of array, and whatever the element at this particular last index, that means array of this last index is, if it is less than the value that I want to search, that means the value that I want to search is is on right side further. So what we have to do, we will have to move on to the next block's last index, which can be obtained by simply updating last index with last index plus block size. Okay. In the next iteration, the next block size, the last index for the next iteration would be index 3, right? Here 0, 1, 2, 3, right? How we will get? In the previous iteration, the last index was 1, the block size is 2. So if I simply add 2 to 1, right, I will get the next block's last index. So that's what I am doing here. Okay. Once this logic is completed, we would have reached a point where this last index could be, holding the appropriate last index for the possible range in the array that we need to apply searching in. So once we have that, we will simply apply a linear search or binary search in that specific block. Okay, here the block size and all those things we will be calculating. How the last but one comparison would have started at last index minus block size plus 1 would be the starting point for that block. From this index till the current value of the last index, we will simply perform either linear search or binary search, and based on that, this linear search and binary search is going to search that specific value that user has passed in that block only. Okay, if it is found, it will return the valid index. If it is not found, it will return -1 as per our understanding. Okay, that is the pseudocode for implementing the jump searching algorithm.